Means versus medians. Students will be able to determine when to use the mean or median as a measure center for a given distribution. In previous lessons, we've learned about the mean and standard deviation, as well as the median and IQR. Now, we want to investigate when we use these measures of centers and spread. When your data or when your distribution is roughly symmetric, you should always use your mean and standard deviation. The mean is the natural center for most distributions. However, if your data is skewed or has outliers, you're going to use the median and IQR. We're going to explore why that is over the next few slides. Take this data set. You have 10 numbers, 1 through 10. Let's find first the median. Okay. So we have the numbers in order, we find the middle two numbers, divide them by 2, and we get that our median is 5.5. Now let's find our mean. When we add all the numbers up, we get 55, divide by 10, and we also get 5.5. When our data is symmetric, our mean and median will be exactly the same. And as your data is roughly symmetric, you'll see that they're about the same value. Let's see what happens when we change one of our data values. So now we have this 60 at the end. We can say that the 60 is an extreme observation or outlier. Again, let's find our median. Okay, we still got 5.5. Nothing changed. Let's see, what do you think is going to happen to our mean though? Pause and think about it for a second. Well, our 10 changed to a 60 and our mean went up. Now we have a value of 10.5 for our mean. So as you can see, because we have this extreme observation or outlier, my mean got pulled very high. Do you think that this mean still represents your data set? Well, think about it. Most of your numbers fell from 1 to 9 exactly. And yet here we have a number 10.5, which is even greater than the highest number that we're saying represents this data set. That doesn't quite seem accurate. In this case, we would say the median is a better measure of the center because it still represents the majority of the values that we see. The mean doesn't quite seem to accurately represent the data because it's being affected by this extreme outlier, the 60. Let's take another example. So this time we have numbers 91 through 100. Let's find the median. We get 95.5. And the mean, we also get 95.5. Excellent. Perfectly symmetric data. Our mean and median should be the same. Now let's see what happens when we have an outlier. Can you spot it? It's this number 1 here. Part of the reason why we may not recognize 1 as an outlier is because it's small. But remember, outliers can happen in either direction. It's an extreme observation that is far away from the majority of your data set. When we look at the median, we still got 95.5. But when we look at the mean, now we got 86.5. This 86.5 doesn't quite seem to represent the most of our data, as it is significantly lower than even our lowest data point here, 92. Again, we would want to use the median to represent this data and not the mean. So key ideas. The mean is not resistant to extreme values or outliers. If a distribution has extreme values greater than the majority of the distribution, the mean will be higher than the median. If a distribution has extreme values less than the majority of the distribution, the mean will be lower than the median. The median is resistant to extreme values and outliers, and therefore we're going to use the median when we have those values come up. So here's a brief summary of when to use the mean and median. When our data is skewed right or left, or has extreme values, we should choose the median to describe the center and the IQR to describe the spread. Both are resistant to extreme values. Remember, median and IQR always go together. If you're using your median, it is inappropriate to use your standard deviation. Now, if our data is roughly symmetric, the mean and median should be about the same, but we're going to use the mean and standard deviation to describe the distribution. Let's get a little bit of practice seeing if we can match box plots and histograms together, because that will give us a good sense of how we expect the mean to be affected, whether or not the data is skewed or symmetric. Take a look at this example in your textbook on page 73. Here we have a data set, a histogram, and we're saying that we want to match a box plot that best matches this histogram so that they would be describing essentially the same data set. Now, if we look at this histogram, even though it has two mounts on both ends, what would you say the shape is? I hope you said that it's roughly symmetric. It is symmetrical. And therefore, we want to identify a box plot that is also symmetrical. Well, let's look here. A is symmetrical. The median is right in the center of this box, and the tails or the whiskers fall out in equal lengths. Same thing with B, and even though C has two indicated outliers, we could also say that this data set is symmetrical. If you look at D, however, we can see that the median is very far to the left, and then we have a long whisker to the right. This indicates that this data set is skewed right? The tail to the right means it's skewed right. This data set has the median far to the right and a long whisker out to the left. This tells us that our data set is skewed left. So we're choosing between A, B, and C. Now, if you think about it, this is a histogram. This vertical axis represents frequency. Even though it's symmetrical, most of my data isn't falling right at the mean and median of this data. It's actually falling out towards the edges. So we wouldn't really expect to see any outliers because these values and these values to the right and to the left are typical. This one could work, but if you remember, within this box, you have 50% of your data. This is a very small box from about 4 to 7. And we wouldn't say that 50% of my data is between 4 and 7 right here. But if we look at this from 2 to 9 approximately, okay, from about 2 to 9, you might say that you have 50% of your data with these tails being so high in frequency. So our answer choice would be A. I want you guys to get a bit more practice figuring out how to match histograms and box plots. So you're going to check out this website here. Okay, so for more practice with histograms and box plots, check out this website. Take a minute, pause the video, and copy it down so you can get it into your internet browser. This is what the website looks like. Let's do one problem together so that you can get a feel for it. So what you want to do is you want to drag each histogram to match each box plot. Let's start with this first box plot up here. Now, our median is slightly to the left, so we expect that we're going to see a histogram with a mound towards the left and some data piling towards the right. That looks like this histogram here. So let's match this mound to this median here, and this tail kind of corresponds to this tail here. These two might be a little bit trickier. Okay. This one's saying that we have an outlier, a small one, right after our data set. This one says, however, that even though it's skewed left and we have a median to the right, that there's a tail going out to the left. So because this data for this first one goes all the way out left, we're going to match it to this tail that also goes all the way out left. This median, maybe one of these last values could be an outlier towards the left. Let's see what happens. Yep, and we were right. And you can get a new data set just like that and try again to get some more practice. So now we're going to go through one problem together before you complete a problem on your own for homework. It says the figure displays computer output for data on the amount spent by 50 grocery shoppers. What they're showing us is our summary statistics with our mean, standard deviation, and 5-number summary. The first question asks, what would you guess is the shape of the distribution based only on the computer output? Okay, well, we talked a bit about this before. When our median and mean are exactly the same, we expect them to be symmetric. However, if I look at this, my mean is higher than my median. And I know that if my mean is higher, I know that there's some amount, some value pulling my data, my mean up towards the right. So we would expect the shape of this data to be right skewed. The next question asks us to interpret the value of the standard deviation. This is a little bit review from previous videos. Remember, the standard deviation is how much do your values differ from the mean on average. So we could say on average, shoppers spent $21.70 more or less than the mean amount spent of $34.70. Notice how I put that interpretation in context. This is always important. And the last question asks, are there any outliers? Well, how can we figure that one out? We don't even have all the data set numbers. Well, we do have the median, the minimum, and the maximum. We even have the Q1 and Q3, but we know that the Q1 and Q3 can't be outliers. So let's see. Do you remember the formula for an outlier? First, you need to find your IQR. Your IQR is your Q3 minus your Q1. 45.72 minus 19.06, I get $26.66. I have to multiply that value by 1.5. I get $39.99. So to find my outliers, I want to first subtract that value from my Q1. I got negative 20.93. No one spent less than that, so I have no outliers on the low end. When I check for high outliers, I get 45.72 Q3 plus 39.99, 85.71. Well, my maximum is greater than that value, so it seems I do have an outlier. There is at least one outlier, the maximum value of $93.34. Now, there could be more values, but we can only be certain of this maximum. Now it's your turn. Consider this problem. Do male doctors perform more cesarean sections, C-sections, than female doctors? A study in Switzerland examined the number of C-sections performed in a year by samples of male and female doctors. Here are summary statistics for the two distributions. First, we have X bar. And remember, X bar means the mean. S of X is your standard deviation. You have your 5-number summary, and here they gave you your IQR. First question, based on the computer output, which distribution would you guess has a more symmetrical shape? Pause the video and write your answer. Explain how the IQRs of these distributions can be so similar even though the standard deviations are quite different. Think about what we talked about in terms of centers and measures of spread being resistant or non-resistant to skewing or outliers. And lastly, does it appear that male doctors perform more C-sections? Justify your answer. I can't wait to see your responses. If you like, go ahead and start responding on the YouTube videos so that other people can hear what you're thinking and that might help them with their responses. Thank you.